deployment. So let's start with a little bit of a review of containerization. So last week we learned about how to package our code into standardized units, building the code into images, running the images in containers, and also pushing our images to Docker Hub. And what this allowed us to do was specify our ideal running environment and easily transfer replicas of that environment across machines. So there was very little setup needed to run the same server the same way. Let's talk a little bit about servers, because what we want to do is deploy our backend applications that we've been writing and put them somewhere. But how and why and where? So servers are software or hardware devices that accept and respond to requests made over a network. So some examples are things like web servers, email servers, identity servers, basically anything on the internet, including, I think, a lot of clients are servers at some level. So let's talk about servers and the network. A server on the internet is given an IP address. IP stands for Internet Protocol. This address distinguishes the server from other servers on the network while it's connected. Every IP address is unique. Users can also connect to servers. You may have noticed, we don't have to type in IP addresses into our web browsers all the time. Users can connect to servers by domain names, which are mapped to IP address by domain name servers. So that's a whole other thing that we don't really need to get into. But basically, there's this mapping that you can register with many different providers, Google, for example, GoDaddy. And those will translate your domain names into IP addresses. So, deployment. Our app has several needs that we haven't really addressed so far in the course. Our app needs to always be running. At the moment, you run your server. It runs as long as your laptop is on or your computer is on, and then you take it down when you're done. And no one can connect to it when it's not running, or even most of the time. But because it's not publicly accessible on the web either. But so our app needs to stay running even when we don't want it running on our personal computers. It needs to be open to receiving requests, which as you've been running, you can only receive requests from people on connected to the same wireless router. We want it to be publicly accessible to the broader internet. It is not all connected to the same router. And it would be kind of nice if we didn't have to really manage this hardware either, I think. So what we can do is rent a server. We want to run our application in the cloud. So we can send our containerized software, which runs the same everywhere, up to the cloud, and allow the server that it runs on to be managed by a cloud service, which will handle physical maintenance, which is good because I don't know about you, but I don't particularly want to be swapping out busted drives on my massive server farms all the time. And it will also provide lots of cool tools to do things that would be just kind of a lot of work for us to do ourselves. Things like security, scaling, and crash management are in large part kind of solved problems, and we can use services that already solve the problems for us instead of solving them ourselves. So some examples of cloud providers that you may have heard of are Amazon Web Services, my personal favorite, Google Cloud, DigitalOcean, which is how Cornell App Dev hosts all of our backends at the moment, and Microsoft Azure, which I haven't tried, but seems pretty cool. It's the only one of the four here that I haven't personally used. So if we've created a server, which we'll go over a bit in the demo, the way you would traditionally deal with a server, well, one of the ways is by if you provision just a raw server with nothing fancy, you'll use the secure shell or SSH network protocol, which is basically a way to just connect and use your server's terminal securely. So you can execute commands, update software, and do all of the configuration just like you might on your local computer on the server that you've rented. So if for one example, that looks a bit like this. Here we We SSH using using a server.pem, which I'll come back to in a second. And we say we give the address appdev at eaterybackend.cornelappdev.com. Eaterybackend.cornelappdev.com, of course, is where the backend for our eatery application is hosted. And appdev is the name of the user on that server that we want to log in as. The -I server.pem is an authentication thing. Server.pem is a key, a private key that we provide to the server, so the server can tell that it's really us. That's just how we're authenticating. So you can authenticate to servers depending on how you've configured them with username and password credentials, unique public key pairs, or private key pairs. So those are some different methods. I usually like to go with the private key method, but they're all valid. So in action, we would simply SSH into a server as a user, providing whatever authentication is necessary. This would need to be added to a known hosts file on your system. So your system, the first time you connect to any remote host, will ask you to verify that this is a host that you like. And if you successfully gotten through all this, you just get a command prompt, and now you can do what you want to do on your server. Now, before we get on to this next part, I'd like to mention we will actually not be doing SSH for PA6 in this class this semester. This was the case last semester as well, but due to some unfortunate circumstances, which are the same reason that this lecture is coming out 2 days late, we actually are going to be using a cloud hosting service known as Heroku, which has some configuration differences, and we will not need to SSH in. In general, there are options on all of the major cloud providers where you won't really need to SSH. It's a good thing to mention, though, because I think it's kind of fun, and if you have the option to SSH, it can be kind of useful for debugging and configuration and trying to figure out what's going on. But it won't be necessary for this class, and in his demo, Rahi will be going over how Heroku works in great detail, so you'll have a good understanding of that. But so now let's look at some optimizations that these cloud hosting providers can also give us. And one of those optimizations is called clustering, which is where we have a group of servers that we can connect together to behave as if they're just one server. And so in some examples, each server could be optimized to do one particular thing. And thus, by connecting them all, we can make it look like it's one server, when actually we have several different servers, each handling individual parts. So for an example, we could have a database server running separately, and this could be a database like PostgreSQL or MySQL, which is much better, faster, and more efficient than SQLite, and can run as a server independently. We could also have a file storage server, and then a server serving an actual web application. So the advantage here, of course, is that some of it, if one of these goes down or gets overloaded, the other ones are still accessible. So in addition to speed boosts from having each of these things running independently, we can also get increased reliability from our entire system doesn't go down at once if we've built it not too tightly coupled. We can lose part of our system and still maintain some subset of functionality. So we can also multiplex multiple servers in front of this, where we can be running multiple servers running our perhaps main application code as well. So the benefits of this are that we have we can have a lot of backups of things, and as I mentioned, when our system goes down, we aren't going to necessarily when some element of our system goes down, we're not going to necessarily lose our entire system to that. and we can focus on fixing, a specific thing. The file, if the file storage server goes down, we know we've got some kind of file storage issue going on. Maybe we're completely out of storage and need to buy some more. But it's immediate, and we know we just need to put that back up. This makes things very easy to manage because they're so segmented. And then this also gives us some really cool stuff we can do with scalability and load balancing. So with load balancing, we put yet another server known as a load balancer in front of our application. And so we can have our application running perhaps 3 times. And the load balancer will accept all incoming requests and redirect them to one of the 3. So it can split the traffic. So instead of one server struggling to keep up with the total traffic, each server can take 1/3 of the traffic. And if our traffic increases massively, then we can scale effortlessly because everything is just behind our load balancer. We can spin up, say, 2 more servers, connect them to our load balancer, and now our load balancer can start sending requests to all 5 servers to better handle the load. So there are a lot of other really cool solutions and techniques related to this that different cloud providers provide for you. There's just a lot of stuff out there, and I really encourage you to look into it. But that's all we have for this week. I hope you enjoyed this lecture. Please, as usual, feel free to come to office hours, reach out on Slack. If you have any questions about cloud providers, things they can do, how this all works. I personally really love deployment and sort of DevOps in general as a thing to do, as an activity. It's just super fun to me. So please don't hesitate to reach out if you have any questions about how any of this system works. I'm more than happy to talk for a long time about it. Anyway, I hope you have fun on this week's assignment, which will be due Wednesday to align with our delayed release of this lecture. And I hope you all have a great week.